Welcome back, Titans. Today we were talking about MedMass, specifically calculating infusion rates. What does this mean? So sometimes in the field or an ER or a clinic or a facility, we're not just going to give a patient a certain dose of medication or a tablet or push something through a syringe into an IV to deliver that medication. Sometimes we have to deliver a specific volume over a specific amount of time. This is going to be like where you hang an IV bag and you're standing orders to deliver it over an hour or two or what have you. So the equation for this is going to be our volume, that's our total mLs. We're going to multiply that by our drip set, which is you using a 10, 20, 60 drop set, whatever it is. And then all we're going to do is divide it by the time, specifically the minutes. That's important. Once you do that quick equation, it's going to give you how many drops per minute you should be setting your flow to. So let's do a couple examples. Let's start with a liter bag. We have 1,000 mLs. That's our total volume. Drip set, let's start with a 10 drop set. That's our macro drip set. That means every 10 drops is going to give you 1 ml. But we're specifically talking about the drop set. Now let's talk about time. Let's say your physician orders a 3-hour time frame. We want 1,000 mLs with our 10 drop set delivered over 3 hours. So let's plug it in real quick. If we plug it into our equation, we have our 1,000 mLs, we have our drip set, which is our 10 drop set that we're using over here, and then the time is going to be 3 hours, but we know that's 180 minutes. So that's important. So let's do 1,000 times 10. That's going to give us 10,000. We're going to divide it by our 180, and that's going to give us 55.56 drops per minute. And that's going to achieve that 1,000 mLs in that 3-hour time frame. Pretty simple. Let's do another one. So let's say we're not using a liter bag. Let's say we're using a 250 cc bag of normal saline, doesn't matter. So 250 mLs. Let's say we're going to use that same 10 drop set. And now let's say we want to give it over 1 hour, which we know is 60 minutes. I'm going to plug it in real quick. 250 mLs. We're going to multiply that by 10. And then we're going to eventually divide by 60. So 250 mLs times our 10 is 2,500. We're going to divide by 60. And that's going to equal 41.6 drops a minute to completely deplete that 250 ml bag with that. Obviously, we can round up. Let's call this 42. So why is it important that you choose the correct drop set for your medications? So I'm going to give you a quick example with a 100 cc bag over 2 different drop sets, and you'll kind of understand why. So let's do 2 different equations. Let's take a 100 ml bag. Let's say we want to deliver it over 10 minutes. Let's say this is our 100 bag of fluid with 150 amiodarone in it, and the order is to give it over a 10-minute time period. So let's use 2 different drop sets and see what happens. So let's say on A, we're going to use a 10 drop set, and on B, we're going to use a 60 drop set. So 100 mLs times our 10 drop set is going to give us 1,000. We're going to divide it by our time in minutes, which is 10. That's going to give us 100 drops per minute. No big deal. So we can achieve that. But let's say we were trying to use a 60 drop set to get our 100 ml bag in. Same thing, 100 mLs times our 60 drop set is going to give us 6,000. We're going to divide that by 10, that's our minutes. And that's going to call for 600 drops per minute. A lot different. So always pay attention to what drop set you should be using and how you're going to achieve that. That is going to be very difficult at all to try to achieve 600 drops a minute and calculating that. So I hope this helps. Always cross-check your medications, and I'll see you next time.